All right, now we're going to go the opposite way, and we're going to be given central angles, and we're going to find the measure of arc length. I always think it's good to have some background knowledge, so they often kind of call arcs two different types. They call it a minor arc if it's the shortest distance connecting two endpoints. So for example, if you look over on the right here, like RS, and you connect just that little part right there, that's a minor arc. The measure of the minor arc is always less than 180, so less than half a circle, and is equal to the measure of its related central angle. And that's what we learned last class. Right, about the central angle and the arc being the same, that's when they're talking about the minor arc. So some examples over here, we had like RS, and if you haven't noticed, they put a little like line or kind of like arc on the top to represent that. Even something like ST over here, that's going to be an arc. VT is an arc. RV is a minor arc as well. Okay, if we then look at major arcs, those are now the longest distance connecting two points. So with RS, if I don't go just from R to S, the short distance, if I go the other way around, we call that a major arc. And these lines are always greater than 180, or half a circle. So the way that we help you kind of recognize we're talking about the major arc is we usually use three letters. So we'll call it like RTS. So then you know you have to go through T to get to S, and you know that it's those three. Or if I could also call that RVS, right? It would end us in the same spot, R to V, and then I keep going to S as the major. Even something, if you did something like VTR, that would be another major arc. Okay, as a reminder from last time, the degree measure of an arc is equal to the measure of the central angle that intercepts that arc. So they're talking about that arc there. Remember, they're talking about the minor arc. So minor arc AB is equal to that central angle that's at Q. So let's go ahead and see if we can find some arc lengths. So to start off, they say, okay, let's find arc GH. The problem with GH is if you look over here, there's no angle that I know right there. However, what we do know is that, do you guys see this straight line that goes to the circle? And we know that a straight line represents the diameter, and that means the angle there is going to be, if I go all the way around here, that's going to be 180. So therefore, if I wanted to find that angle over here on the left, I'm going to do 180 minus the 51 and minus the 59. When I do that, I end up with that angle over here on the left is 70 degrees. And if GFH is 70, that means that arc is also 70 degrees. Okay, now let's look at the next one. The next one asks us for GKJ. Notice once again we have that diameter that it's connecting, so you should recognize that that's going to be equal to 180. So if this angle here is 180, then the arc also has to be 180. Okay, on the last one, we've got K to H to I. With this one, I always look for that 180. So notice there, right there, you got the straight angle. So this whole part here, from K to G to H, is 180. And then I've got H to I, which I know that central angle is 51, so this is also 51. So I'm going to take 180 plus 51, and I end up